Hello everyone, this revision video focuses on column vectors. Now what is a column vector? Now a column vector basically represents a horizontal shift in the vector and a vertical shift. Now here I have four vectors and we're going to be looking at how each of these vectors can be represented as a column vector. Now before we do that, let us recap or revisit the concept of the Cartesian plane. Now your Cartesian plane is made up of two lines intersecting at right angles. Alright? Now at the center, the intersection of these two lines is considered to be our origin. Alright? Now to the right hand side of our origin are positive numbers, to the left hand side of our origin are negative numbers. North of our origin are positive numbers, south of our origin are negative numbers. Alright? Now this can also be interpreted as a movement towards the right from the origin is a positive movement. Alright? A movement towards the left is a negative movement. A movement southwards from the origin is considered to be a negative movement, and a movement towards the north from my origin is a positive movement. Alright, so we need to take into consideration those directions when we are talking about our column vectors. Alright, so let's look at question A. Now question A has a vector AB. Alright, so what this means, it simply means that we are moving from A, so A is our starting point, and B is our ending point. Alright, so we're moving from A to B. Now to find this column vector, we need to take into consideration the horizontal movement and also the vertical movement. So let us begin. Alright, so the horizontal shift. This horizontal shift, if you notice, we're moving from A to B, so it simply means now that the horizontal shift would be a shift moving towards the right. So if you can recall our Cartesian plane, right, if we're moving towards the right, then it means that our number should be positive. Alright, so our shift will be positive rather. Alright, so let's count the shift. So that will be 1, 2, 3, 4. Alright, so our horizontal shift is equal to 4, and our vertical shift is 1, 2. Alright, so this 2 is positive. Remember, all movement towards the north are positive. Alright, so once again, our horizontal shift is 4, our vertical shift is 2. Hence the column vector 4, 2, 2, or 4, 2, sorry. Alright, so let us look at the second vector, vector C to D. Alright, so let us think about the direction of this vector. So if we're moving from C to D, 1, you will realize now that our vertical movement is downwards. Alright, so from our Cartesian plane, any movement south would be a negative movement. Alright, so let us count the vertical shift. So that is 1, 2, 3, and 4. Alright, so it's a downward movement, so that 4 is negative. And the horizontal shift now, so going back to our Cartesian plane, our horizontal shift would be a movement towards the right, so that is 1, 2. Alright, so our numbers towards the right are positive, hence our horizontal shift is a positive 2. So we can safely say that the column vector for C to D is equal to the horizontal shift of 2, the vertical shift of -4. Alright, so that's it for the second vector. Let's look at the third vector, H to G. All right, notice I did not say G to H, I said H to G because noting the direction of the arrow indicates that we're moving from H to G. So H is the starting point and G is the ending point. All right, so once again, let's look at the direction of movement. Now, if we're moving from H to G, it means that we're moving upwards. All right, so going back to our Cartesian plane, if we're moving north, then that shift is going to be a positive shift. All right, so that is 1, 2. All right, now our horizontal shift now, if we're moving from H to G, which means that we will be moving left, so that will be 1, 2. All right, so any movement towards the left is going to be a negative shift. All right, so based on this vector, I can safely say that if I'm moving from H to G, then my column vector is going to be equal to -2 and +2. Okay, so let's move on to the fourth vector, E to G. All right, E to F, sorry. All right, so we're moving from E to F. So let's write the abbreviation first for clarity. All right, so if we're moving from E to F, once again we're moving downwards. All right, so if we're moving downwards by the Cartesian plane, a downward movement is going to be negative. All right, so we would have shifted 1 unit, 2 units, 3 units. All right, so 3 would be the vertical shift, -3, sorry. All right, now we will be moving 1, 2 units towards the left, and based on our Cartesian plane, any shift in the left direction is negative. So we would have moved 1, 2 units towards the left. So it simply means that the column vector for E to F is -2 and -3. Alright, so that concludes this revision video. If you have any other topics that you would like me to review or to revise with you, I'm here at your service. Don't forget to like, comment, share, and subscribe.